Hey everybody, thanks for your patience while I was on vacation. Let's go ahead and start with a nice quadratic factoring review. The first thing you'll want to notice about this problem is there are only two terms. So when there are only two terms, the first thing you want to check is, could this be a difference of squares? And the way to check that is 64 something squared? Yeah, it is. It's 8 squared. And is 4 something squared? Yes, it is. It's 2 squared. And is y squared something squared? Yes, it is y squared. Is that a sum or a difference? It is a difference. Therefore, this is a difference of squares. So then we want to remember how a difference of squares factors. If this is new to you, go check out this video where I do it more slowly, but we'll remember that it factors into the square root of that first term minus and plus, or plus and minus, it doesn't matter, the square root of that second term. And that is as far factored as 64 minus 4y squared can go. All right, solve. Next. All right, our second problem is the classic 3-term quadratic, a squared term, an x term, and a term that has no x or an x to the 0. When I see this, the first thing I'm going to do is use the x method. If this is new to you, check out this video where we do it a little more slowly. But if not, we're going to remember that in our top, we put a times c, and we remember we have to include the sign of anything. So that's 6 times negative 10 or negative 60. And down here, we go ahead and put our b, which is 11. And the question we're asking ourselves is, what multiplies to negative 60 but adds to 11? The fastest way to do this is to make a quick factor list of 60. And so those are our factors. So we don't worry about the negative yet. We're asking ourselves, if we assign a negative to one of these guys, can they add together to make an 11? 1 and 60 cannot, 2 and 30 cannot, 3 and 20 cannot, 4 and 15 has potential. If my 4 is negative and my 15 is positive, that would add to a positive 11. I'm going to quickly check the rest. 5 and 12 don't work. 6 and 10 don't work. I'm good. And as I said, we know that our 11's positive, so our larger of our two factors wants to be positive. Now, we are not done. Because our x squared term has a coefficient, these are not what go directly in the parentheses. We now move to factoring by grouping. This is not familiar. Check out this video. Otherwise, we go ahead and rewrite our original quadratic like this. So our 6x is our first term, and our negative 10 is our last term. But we've re-represented 11x as minus 4x plus 15x. That's what we were doing down here, is we were finding the coefficients of our inside and outside from our FOIL. If FOIL is not familiar to you, go take a look at this video. Otherwise, we're going to continue on by grouping. That means we're going to put brackets onto this. We're going to take the greatest common factor out of each of these. So a 6x squared and a minus 4x. I can see that I've got a 2 in both of those, and I've got an x in both of those. So I factor 2x out, and what remains here, this is division, is 3x. And I take my 2x out through division, and what remains is negative 2. Now I'm going to look here. 15x and a minus 10. What's common to both of those is a 5. I pull that out. What remains of my first term when I divide out a 5 is, that's right, 3x. And what remains of my second term when I divide out a 5 is, and now what's inside the parentheses is the same. Great. If it's not, you either did something wrong or this isn't factorable by grouping. Okay, but it is the same. And so now I'm going to pull this out of both of these two terms. And what's left in this term when I divide out this is 2x. And what's left in this term when I divide out this is positive 5. And that is the factorization of this, starting with the x method, writing it out in our firsts, outsides, insides, last, factoring by grouping. Excellent. Okay, one more in our practice set today. All right, another classic 3-term quadratic, an x squared, an x, and no x. Now, I notice that this starts with a 3 But I noticed that there's a 3 in a 6, right? 3 times 2, and a 3 in a 72. That's 3 times 24. If you're not sure, the little hack is add the digits. 7 plus 2, that's 9. If that result is divisible by 3, then the whole number is divisible by 3. So before I go factoring, I'm going to factor a 3 out of every term. And that's going to be a whole lot easier. Now I don't have to do factoring by grouping at the end. All right, I'm going to throw my X method on the page. A times C in this case is negative 24. B is negative 2. I'm asking what multiplies to negative 24 and adds to negative 2. I'm going to write my quick factor list. Okay, a quick look through here shows me that these guys are 2 apart. I need my result of addition to be negative, so my larger of the two numbers wants to be negative, so that's a 4 and a negative 6. And now, because my x squared has no coefficient, right? Because I factored the 3 out at the beginning, these are the two numbers that go straight into my parentheses. So my final factorization is 3 times x plus 4, x minus 6. Okay, excellent work, you guys. Run those again. Press pause before I get to work. See if you can do it. Then check and see if we got the same answers. Go ahead and click on any of the links I mentioned during the video for some extra support. Go ahead and check out my factoring playlist, which has a whole bunch of different factoring methods, factoring problems. I think it even includes a difference of cubes, which we didn't get to this time because I called this one quadratic. Leave in the comments any problems you'd like some help working on. And as always, keep on mathing.